Hi, welcome to LISP Your Mesh to Shape. I'm Reinaldo Togores, architect and industrial designer. I've been teaching AutoLISP programming for the past 18 years to civil and industrial engineering students at the University of Cantabria in northern Spain. During these years, I have authored a couple of books on this subject. This class title might seem a bit like a tongue twister, but it certainly describes what we'll be doing here, using AutoLISP to create mesh objects with an unlimited variety of shapes. The one I've used for this title slide is an example. Our class will be split into several modules in order to make it easier for you to find the specific content you are interested in. This way, you can watch one of the modules and take some time to test things in your computer before continuing to the next one. AutoLISP and its new flavor, Visual Lisp, have been for a long time the expert AutoCAD users' way of extending the program to satisfy their needs. Meshes come in as boxes, cones, spheres, etc. Of course, we can manually push and pull their vertices to finally arrive to the shape we want. But how much pushing and pulling would it take to build a shape like the one I've used for our title slide? What if the shape I need is a dodecahedron? That's where AutoLISP comes in handy. This class will show how. We can do all our stuff in AutoCAD, that's fine. But we can find these shapes can also be used in other programs. When working in 3D, setting our point of view, type of projection, and visual style are also important. Our title image was automatically colored using AutoLISP. That's one of the things we will be able to do. To make mesh objects, we must understand which values must be assigned to the DXF group codes in its entity definition list. Once this has been made clear, we will see how they can be made and modified through classic AutoLISP. Further editing possibilities can be attained by converting meshes to surface and solid objects, and the resulting objects can be exported to programs like Revit or Max. In this context, you can profit by attending other classes on conceptual design at AU 2012. A detailed explanation of all the Lisp code is included in the handout we've prepared. There's also a dataset that includes all the functions we're going to use and some example drawing files. We recommend downloading both the handout and the dataset in order to follow the different modules. The contents of this class have been adapted from my latest books, Chapter 19, which deals with managing mesh objects through AutoLISP. The book's title, AutoCAD Expert's Visual Lisp, reflects its purpose, supplying the knowledge that qualifies an AutoCAD user as a real expert. While we wait for you to download the handout and dataset, we'll take a couple of minutes for showing some example of our shaped up meshes. I hope the examples shown have served to whet up your appetite. If so, I'll be seeing you in our next module, which deals with the ways of examining, loading, and executing AutoLISP code. See you soon.